Today's video is all about 8.2 asymptotes. There are two types of asymptotes. The first one is vertical asymptotes and the second one is horizontal asymptote. So we can refer to the graph below. From the graph, the red dotted line where labeled as x equal to negative a is the vertical asymptote, while the one with the blue dotted line labeled as y equal to b is the horizontal asymptote. What is vertical asymptote? Vertical asymptote is a line where x equal to a. So what should we do to prove that the line x equal to a is vertical asymptote? The first one, we need to find limit x approaching a from right for the function and also from left of the function. If you get the value either positive infinity or negative infinity as the final answer, hence the line x equal to a is the vertical asymptote. Next, we look at the horizontal asymptote. What is horizontal asymptote? If you have a line labeled as y equal to b, this line is a horizontal asymptote if when you try to find limit x approaching positive infinity for the function is equal to a value b, and also limit x approaching negative infinity for the function is also equal to b. Note that for horizontal asymptote, we are interested in the behavior of x approaching positive or negative infinity. Let us look at question 13H, which they ask you about what asymptote do the graph have. So you need to look and try to find either there are involving vertical asymptotes and also are there involving a horizontal asymptote for this function. So I'll pick question 13H. So fx is equal to 2x over third x squared minus 9. So the first thing is you need to check for the domain of the function. Okay, so what should you do and what should you refer first? You need to look at the denominator. So the denominator of a fraction for x squared minus 9, okay, that cannot be 0. So hence that is the first thing that you need to note. The second thing is anything inside third should be always greater than 0. So x squared minus 9 should always greater than 0. So by simplify this one, okay, you'll get x minus 3, x plus 3 should greater than 0. So by smile graph, this is negative 3 and this is 3. So greater will take the above x axis. So what should you have? The domain for the function is from negative infinity to negative 3 union 3 to infinity. So when we get the domain, what should you notice here is you need to check the limit from x approaching negative 3, x approaching negative 3, and from left and right, and also x approaching 3 from left and right. Okay, so we look for the vertical asymptote first. Vertical asymptote. So we have two values here. The first one, if x equal to negative 3, we find the limit. We're going to find the limit x approaching negative 3 from left. So the function here is 2x over third x squared minus 9. Okay, so when you try to substitute here and you try to solve, you get here 2 times negative 3 over 0, of course, negative 6 over 0. The answer should be actually infinity, but we don't know either it is positive or negative. So we just need to check negative 3 from left pick a value. For example, let x equal to -4. Substitute inside the function. So you get -4 square minus 9. Okay, when you calculate this one, you get cert 7. So cert 7, the value is positive. So here 0 is 0 positive. Negative divide by positive, you get negative. Okay, and then you find limit x approaching -3 from right. So here the function is 2x over cert x square minus 9. The same things, when you try to substitute, you still get -6 over 0. So the answer would be either positive infinity or negative infinity, but you should refer from right. So let's say x equal to 0 from right. So cert 0 square minus 9, you get cert -9, which is, this is not no solution. So when this is no solution, you cannot write it down like that. Okay, so you just write it down undefined. Okay, even though you get one side is undefined, still, because it still have the vertical asymptote. Since the definition of vertical asymptotes, you need to find limit x approaching a from left for function fx. You either get positive or negative infinity, and there is a statement there, or limit x approaching a from right for the function fx. You need to have it, the final answer, as positive or negative infinity. The statement here is or. Okay, you don't have to find both lah. If you already have one side of limit that gives you the value of positive or negative infinity, hence you can state that x equal to the value is the vertical asymptote. So from this statement here, okay, you can see that you get the left-sided limit of x approaching -3 from left. You get the value is negative infinity. So for first part, therefore, x equal to -3 is the vertical asymptote. But this is not just that particular thing. You need to remember, you need to find another value of x, which is x is equal to 3. So next, we try to find we try to check the vertical asymptote for x equal to 3. Okay, so I'll clear that up. So if x is equal to 3, then still you need to find both. So limit x approaching 3 from left side for function to x over cert x square minus 9. When you substitute, you get 6 over 0. Okay, so should be the answer is infinity, but you need to check the 0 below. Okay, so it is 3. You need to find the value of you need to pick a value of x from left side of 3. So let x equal to 0, let's say, and you try to substitute 0 square minus 9, you get cert -9, which is no solution. So since there is no solution, you cannot write it down as infinity. The answer here should be just undefined. Okay, again, you need to find the next another side of limit x approaching 3 from right. So for function to x over cert x square minus 9, so same goes, you'll get 6 over 0. So we notice that 6 over 0, the answer will be infinity. Either you need to check either it is positive infinity or negative infinity. So from right, so let's say I pick x is equal to 4. So cert x 4 square minus 9. Okay, so 4 square minus 9, I'll get 7. So cert 7 would be in positive sign. So 6 is positive, 0 is positive, so you get positive infinity. So hence, when you get at least one side of the limit for x approaching the value is positive or negative infinity, hence you can give the conclusion. Therefore, x equal to 3 is also a vertical asymptote. Okay, so therefore you get two vertical asymptote lah. The first one is x equal to negative 3. Okay, another one is x is equal to 3. Okay. So, just now we already find the vertical asymptote. So, next we're going to find the horizontal asymptote. So, notice that if you want to find the horizontal asymptote, we need to find the limit of x approaching positive infinity and also negative infinity. So, we try to find limit of x approaching positive infinity first for the function 2x over third x square minus 9. So when you substitute here the value of infinity, you will get the case of infinity over infinity. So then you need to divide by the highest power of denominator. So here the highest power of denominator is third x square. So you will get limit x approaching positive infinity 2x over third x square for the numerator. And for the denominator, you get third x square minus 9 over third x square. Okay. So actually, for the denominator, you won't have any problem since by the properties of third A over third B, it can be written as third A over B, right? So that is, you just use this property. For the denominator, you get third x square minus 9 over x square. Okay, so how about the denominator part? Okay, for the denominator part, you still need to remember, we have the definition of third x square, which is equal to modulus x. So this one is actually, we can split it into 2 for x is greater or equal to 0 and also negative x is less than 0. So remember, you try to find the limit for x approaching positive infinity. So you need to pick the value of positive part. So here you get 2x over x. Okay. Alright, so by solving this part, you get limit x approaching positive infinity. So for the numerator, you get 2. And for the denominator, you get 1 minus 9 over x square. So next, you just need to substitute the value of infinity inside. You get 2 over third 1 minus 9 over infinity square, which is infinity square is infinity, 9 over infinity, you notice you will get it 0. So 2 over third 1 minus 0, the answer would be 2. Okay, so from this calculation, the statement that you can came out with is, therefore y equal to 2 is the horizontal asymptote. Okay, so last part, we already try to find limit x approaching positive infinity and we end up with y equal to 2 as the horizontal asymptote. So now we need to find a limit of x approaching negative infinity for the function 2x over third x square minus 9. Okay, same goes with this one. We'll get the case of infinity over infinity, so we need to divide numerator and denominator with the highest power of denominator, so we'll divide it with third x square. So 2x divided by third x square for the numerator, and denominator will came out as x square minus 9 over third x square. So again, the denominator, you won't have any problem with it. So how about the numerator? Remember back, we have this kind of definition. Okay, so now you try to find the x approaching negative infinity. Hence, we need to pick the definition of negative side. So you end up with limit x approaching negative infinity. So for the denominator, you end up with 1 minus 9 over x square. Okay, but for the numerator, you left with 2x over negative x. So you simplify, you'll get limit x approaching negative infinity, negative 2 over third 1 minus 9 over x square. Hence, by substituting the value, you'll end up with negative 2 over third 1 minus 0. So the final answer is negative 2. But you need to write down your conclusion. So therefore, y equal to negative 2 is the horizontal asymptote.